Okay. So 3.2, sum and difference formulas. They're giving me the cosine of 45 minus 60. How are we going to do that? We could subtract those, and what is that, minus 15 degrees? Yeah, minus 15. Cosine of minus 15 degrees. Do you guys know the cosine of minus 15 degrees? No, that's not one of our memorized values. You guys know what I'm talking about. See how they say exact value here? That means they won't take a decimal. I mean, you can take your calculator and hit the buttons and you'll get a decimal, but type it into MathXL and MathXL will go, I don't want a decimal. Because decimals are always rounded. The decimal goes forever. You guys have your calculator? Let's get a decimal first. What do you got?
I got root 6 plus root 2 over 4.
Root 6 plus root 2. Yeah, give me a decimal. Can you hit the decimal version?
0.965925863. 0.9659.
Great. I'll just stop there. 0.9659. So that's the decimal. If you typed that in, MathXL, they won't be happy. They won't take it. They want the other kind of answer you were giving me. They want the root answer because that one's exact. Because this decimal, it goes on forever, right? On your calculator. That decimal goes on forever. So anywhere we stop, it's not exact anymore. You see the problem? So when they say exact means not a decimal. Because the decimal goes on forever and we'd have to round it, and then it's not exact. You with me? So when they say they want an exact answer, they're saying, I don't want the decimal answer. I want you to give me the root. Yeah, use radicals as needed. They want the root answer that Chinu was giving. Well, how do we get that? How do we go about this? This part will also be on the non-calculator part of the exam. Because we can get this answer without using our calculator. How? How do we get like an exact root answer without using our calculator? Well, we have a special formula in this section, the sum and difference formulas. Let me give it to you. It basically says, let me write them all out for you. The sine of two angles added, I'll call it A plus B. The sine of A plus B is sine, cosine, cosine, sine. And then you just put in A, B, A, B. So A, B, A, B, with a plus in the middle. Okay, did you follow that? So the sine of two angles added. The sine of two angles added is sine, cosine, cosine, sine. Everybody see the pattern there? So the sine of two angles added is sine, cosine, cosine, sine. Sine, cosine, cosine, sine. A, B, A, B. Everybody see that? I still remember my buddy when him and I were at junior college up in Sacramento, and I remember him saying, whatever reason, he said to me, this formula. I remember talking about this formula. I mean, that's what we did. This was our life. That and playing on the little tennis team. We just memorized these formulas because we wanted to go to college and get a real. He's an engineer back with GE now, back east. So I'd encourage. I mean, you can put them on a 3x5 card. My teachers made me memorize them, but you can put them on a 3x5 card. But it will help you to know them cold. So sine, cosine, cosine, sine. You just want to say that a million times. Sine, cosine, cosine, sine. A, B, A, B. So there's that one, and then the cosine formula, because that's what we really need on this problem. The cosine of two angles added together is cosine, cosine, sine, sine. It's a little different. Like that. It's the opposite. And then he's the opposite sign. So he's going to be minus in the middle. Again, it's the AB, AB. But he has minus in the middle, not plus. Everybody chalking with me on that? Everybody see what's happening there? Notice that his signs are opposite, right? Sine has plus in the middle. Cosine leads to minus in the middle. So the sign switches for cosine, doesn't it? Plus originally, minus in the formula. Sine stays the same. I remember my buddy, Dan Robertson, who was in junior college with me, he would always say sine, cosine, cosine, sine, cosine, cosine, sine, sine, and cosine is not your friend. That was his, I still remember, that's like 30 years ago. His different way of memorizing the formula. I'm just bringing it up to say that's what successful math science people do. They give their life to this and they memorize formulas and they say them and it's their life. So sine, cosine, cosine, sine, cosine, cosine, sine, sine, and cosine is not your friend. That's what he said. Meaning it switches signs. Cosine is opposite sign there. Like that. So if that helps, there you go, whatever. You can put them on a 3x5 card, but it's nice to know them cold too. It helps you go quick and be accurate. All right, so there we go. So what does that mean then? Getting back to the original problem. Cosine of these two angles subtracted, what does that mean? Well, if we're going to write it out, it means cosine, cosine, sine, sine. You with me? 45, 60, 45, 60. Do you see how I'm just following the pattern of this formula? Cosine of two angles is cosine, cosine, sine, sine. First angle, second angle, first angle, second angle. AB, AB. Right? 45, 60, 45, 60. Everybody tracking with me? But cosine is not your friend. What did my friend mean by that? He meant whatever sign's in the middle of the cosine, it's the opposite in the formula. So it'd actually be plus on this one, because the original had minus. Everybody see that? It's the opposite. So if cosine originally has plus, then it's minus in the formula. If it originally has minus, it's plus in the formula. It's not your friend. It tries to trick you. It does the opposite in the formula. Whereas sine keeps it the same. I didn't want to write out the other version. I could. I could write for you. Then sine of A minus B, and it'll be all the same stuff with minus in the middle. And cosine of A minus B, well, it'll be all the same stuff with plus in the middle. Does that make sense? Cosine's not your friend. It switches the sign in the middle. Okay. So this is it. See how I came up with that? Now, though, we have 4 separate problems to figure out. Do you realize that? We got to find cosine of 45. That's the whole unit circle, small, medium, large thing. And then we got to find the cosine of 60. That, again, is the whole unit circle, small, medium, large thing. And the sine of 45. And then the sine of 60. This is not easy, but they're kind of similar parts. So let's go through it. So basically, we have to do a 45-degree angle and find the cosine and the sine. Then we got to do a 60-degree angle and find the cosine and the sine, don't we? So really, we just need 2 different angles. So let's go to the unit circle. Let's do 45 first. 45 is right in the middle, isn't it? That's the easiest one. 45 is right in the middle, which means he's over medium, up medium, isn't he? Remember that one? Now, you're getting that down at this point in the course. If you're not good with the small, medium, large unit circle thing, you got about a week, and then you need to drop this class and do something else that's going to work out this semester. Seriously. And I hope that doesn't land negatively. I would say that to my children who I care about and want good for. That's the truth. It is no way you're going to pass this class if you don't have the small, medium, large thing down by the end of this week. That's not going away. I am glad. If you come spend a half an hour with me, I bet I can bring you up to speed on that. But make sure, don't be unwise. The unwise thing to do would be to just kind of keep stringing along, hoping something magic happens without learning these kind of things. It's not going to happen. You just waste your time. So learn it, get it down. Make sure you know the small, medium, large thing to where you can just nail it out. So remember the small, medium, large? It's what is it? 1 over 2, root 2 over 2, root 3 over 2. Right? 1, 2, 3 over 2. Remember that? Small, medium, large. So this is medium, medium. So it's root 2. Whoops. It's root 2 over 2. Plain 2. And root 2 over 2. So that's the coordinate. So both sine and cosine are root 2 over 2, aren't they? They're the same. Because it's medium, medium. So therefore, cosine of 45 is root 2 over 2. Sine 45 is root 2 over 2. They're the same. Good so far? I'll go on to the 60-degree angle now. Now let's do the 60. 60-degree angle. So, which is right here, 60 degrees, right? That's over a small amount, up a large amount, isn't it? So the small amount's a half, the large amount's root 3 over 2. Cosine is always the x, sine is always the y, isn't it? So the cosine of 60 is a half, times, this is times in here, right? This is times, plus, and this is times here. Sine of 60 is root 3 over 2. There we go, we found the 4 parts. We okay with all that? Now we just need to multiply those and combine like terms. Or common denominator, I mean. Get this out of the way. Okay, so now, what do we have? Root 2 times 1, which is root 2, over 2 times 2, which is 4, plus root 2 times root 3, root 6, over 2 times 2, 4. Am I going too quick? Is that okay? So far, so good. Right, I just multiplied those together. I just multiplied numerator times numerator, denominator times denominator. Found that. That good? So root 2 times 1 over 2 times 2. And then, now these are common denominators, so just make them in, you don't need to make them two separate, you can just make it one big fraction. I cannot add these roots on the top. You cannot make that root 8. I don't know if you remember the roots from your algebra days. Glad to go over that in more detail with you. But they need to stay separate. They're unlike roots. They can't add together. They can multiply. See how I multiplied the two roots here? That's fine, but they cannot add. They're unlike terms. It's just like trying to add different letters. They have to just stay separate like that. And that's it. That's our answer. That is the, and if you check that, if you turn that into decimal, it is the point, whatever, that decimal we had. It's the same thing. Questions on that one? We good? All is well? We are happy? All right. That's kind of the same thing on all. Okay. Okay, so, yeah, so now they're having us do the formula backwards. So everybody see this? So they're giving me the formula, and they want me to actually do it backwards. So it's already spread out. So remember the so do you see that that's the cosine formula? Why? Why is that the cosine formula? Because it's cosine, cosine, sine, sine. That's how the cosine formula goes. Let me write out the cosine formula. The cosine of two angles added is cosine, cosine, sine, sine. A, B, A, B. A, B, A, B, and he's not your friend. Cosine is not, sine's your friend, cosine is not. So just write out the formula. Again, it's good to write it. So we have it written out there, we look at it, and we say, okay, so there it is. That's obviously what they're doing. And they're wanting me to go backwards. They're wanting me to start with this, which is the right side, and go back to the left side. Is everybody seeing that? So the right side, cosine, cosine, sine, sine, that's what this is. This is the right side. And they're just saying, hey, what's the A? They're calling it alpha and beta, whatever, A and B, what do you want to call it? What are they? What are the two angles they're putting in there? Well, it's those two angles, 79 and 49. That's a no-brainer, huh? And then, part B, this is all the same as what? How did I come up with cosine 30 degrees there? I had it wrong at first. Yeah. Now, this is because cosine is not our friend. Right, and I forgot that at first. I messed up. Forgot my buddy's little memory device. Notice what sign do we have in the middle here? Plus. We have plus in the middle. So that means we actually have minus. Remember, it's opposite. Cosine is not your friend. He tries to fool you. He does the opposite. Whatever he puts in the formula, whatever sign he puts in the formula, he does the opposite sign in the main part. So since this has plus here, it must mean minus in the main A and B. Cosine of A minus B. You tracking with me on that? Does that make sense? I didn't notice that at first. I tried adding the angles and had the wrong answer. I don't know if you noticed. So that means this formula has plus, so therefore I've got to take the A and the B, which are 79 and 49. It's the cosine of 79 minus 49. That's why the formula is becoming plus. So what is that? That's cosine of 30. when you subtract them. That's what they're asking you. It's cosine 30. And then the final question. What's the exact value of that expression? What's the exact value? Now, what do they mean by exact value? They want me to take the unit circle. Whenever they say exact value, they're talking unit circle. Take the unit circle, put the cosine of 30 on it. So if I do that over here, do 30 degrees, unit circle. Here's 30 degrees. Over and up, right? Over a large amount, root 3 over 2, up a small amount, half. Which one's cosine? Cosine's x. Sine is y. Always. Cosine, root 3 over 2. So the answer, the exact answer to cosine of 30 degrees is root 3 over 2. We're done. Is that good? Questions I can answer? All right. Okay, so we have cosine of a plus b. I'm just going to write a and b. Cosine of a plus b in the top up here. So cosine of a plus b up there. What do I do with cosine of a plus b? Yeah. Write the formula. Yeah, the formula I've been using. It's cosine, cosine, sine, sine. He's not our friend. So plus here means minus there. AB, AB. AB, AB. So that good with the numerator? So that's just the top. That's just the top of the fraction. Write the left side numerator in terms of a sum or difference formula for sine and cosine. So I did that. Okay. So that's the first thing they want you to do. Now look where we're going. Look at the goal here. They want me to make it cotangent of A times cotangent of B minus 1. How's that going to happen? How is this? Well, here let me put it. What's it over? It's over sine A sine B, right? That's the denominator. So it's over sine A sine B. Good so far? Now, how is that going to become that? How could that be?
You could split the fraction.
Exactly. Right? That's two things separated by plus or minus over common denominator. Separate them. Separate them. So cosine A cosine B over sine A sine B minus sine A sine B over sine A sine B. Good so far. I just separated them. We've done this a couple times today already. Separated them over a common denominator. Right? They both have the same denominator, sine A sine B. So I separated them. And now what is this? That's your 1. And now, what is cosine divided by sine? There's two separate cosine over sines there, huh? What's cosine over sine? Cotangent. Remember? Because tangent is sine over cosine. Cotan is upside down, is cosine over sine, isn't it? So cosine over sine, this is cotan A. This is cotan B. With I already got the minus there, I guess. There it is, minus 1. That's how they got that. We good? Another little proof there. They're going to weave. Now, it's not going to be like a whole bunch of proofs now. Let me comfort you. They're just going to weave 1 or 2 in now. And then that's all. Not a lot. Questions I can answer on that one? Y'all got that one copied down? Is that good? All right. Like that. So here's just a normal, regular, can you do the thing? Let's do that. Let me let you guys try it. So sine 45 degrees minus 30. Okay, give it a try. So just write out the formula. You know, right? You got it in your notes now. So write out that formula. So the formula is sine, cosine, sine. So that's the sine formula. Sine, cosine, sine. He is your friend, which means, right, sine's your friend, cosine's not. Whatever sign you start with, it'll be the same in the formula. So we started with minus, it'll be minus in the formula. And now just put in the angles. 45, 30, 45, 30. Forty-five, 30, 45, 30. And now do little units, draw a little unit circle, figure out the sine and cosine of 45, the sine and cosine of 30. Excuse me. So draw a little unit circle. 45 degrees is in the middle. Medium, medium. So you know 45, so the sine is root 2 over 2, isn't it? And so is the cosine. Whoops. This one, I mean, is root 2 over 2. So sine of 45, cosine of 45 are both root 2 over 2 because they're medium, medium. Good so far? And now, let's do, what is it, 30? Okay, we'll do 30 degrees. 30 is the close one. 30. So that's over a large amount, up a small. Over large, up a small. Over root 3 over 2, up only a half, isn't it? So that, and sine, cosine is x, sine is y. So cosine of 30, root 3 over 2, sine of 30 is the half. And there's minus in the middle. We good to there? It's making sense how to do that. Just laying out that formula. You have that in your 3 by 5 card. Okay, now multiply. Root 2 times root 3. Root 6 over 4 minus root 2 times 1 is just root 2 over 4. This looks a lot like the answer we got last time. Just a minus in the middle or something. On that. And there we go. There's the exact value. That's what they want. Exact value, no decimal for that one. Good? Questions on that? All right, I'll move on. So, cosine of 45 plus 150. What do we do with cosine of 45 plus 150? Yeah, so break it into what's the cosine formula? Cosine, cosine, sine, sine. Right? He is not our friend, so plus in the beginning leads to minus in the formula. Opposite sign. All right? Take it from there. So write in 45, 150, 45, 150, and find those values. So the 45 is easy. That's root 2 over 2. Same thing with the sine. Those are medium. You know those are medium. Now do the cosine and the sine of 150. So draw 150 degrees, unit circle. Right, we've done that before. That was back on exam 1. So draw a 150 degree angle on the unit circle. So 150 is right there. No, that's not true. I have 150 going past 180. Excuse me. I'm having trouble today. My throat. So 150 is right there. 150 is just before 180. It's right there, 150 degrees. Because 180 is halfway. All right, so 150 is there. What is that location? Well, remember we need to go, it's back a lot, isn't it? It's back a large amount, up a small amount. You with me on that? It's back a large amount, up a small amount, isn't it? To 150 degrees? That means it's back root 3 over 2. It's up a half. The cosine is always the x. The sine is always the y. So, cosine of 150, negative root 3 over 2. Sine of 150 is positive a half. And we have the minus in the middle, don't we? Good to there? Everybody see how I found all those values? Now, you don't have to, if you're worried about the negative, positive stuff, you can just do the all students take calculus. All students take calculus. So we are in the second quadrant where only sine is positive. And his reciprocal, but we're not doing that. Sine is positive. The other ones are negative. So it makes sense that the sine is positive in 150, and the other ones, like cosine, is negative. You can just do that, right? If you want to make it as easy as possible. Okay, so then multiply those values together. What are we going to get? We're going to get root 3 times root 2 is root 6 over 4. It's negative. Minus, because of that minus sign, root 2. It's almost the same answer again. So it's minus root 6 minus root 2 all over 4. They're just both negative this time, and there we go. Questions on that? We good? All right, let's stop there.